Hello, everyone. Welcome to eBizChat, where it's all about business. My name is Rick Zanotti, and I'm joined by Dr. Susan Nash. We will be your co-hosts. In studio, Harold Muliati is our video producer, and we've got a great guest today. We've got Alex Finch. He's president of Tri-D Dynamics, which should be a pretty cool interview. They're doing some stuff nobody's really done before. It's going to be exciting. Here we go.
More and more people are working remotely every day. Your company may already be remote. You may be new to working remotely, whether you're a worker or a manager. Working remotely has some challenges and some very good points to it as well. In our training, we'll make sure that you learn how to work remotely, how to build trust, how to do all the things that make remote working successful. And we'll also talk about some of the pitfalls and what to avoid. Working remotely for workers and managers. It's our new course on Udemy. Thanks.
And we are back, and in that center, we like to call it the center position of power. That would be you, Alex. Alex Finch. How are you today, Alex?
Doing great. Pleasure. Thanks for having me on the show. Watched a few of the episodes in prior past and big fan. So appreciate to speak on behalf of Tri-D Dynamics today.
That's great. Now, you guys are a young company. You're pretty brand new. It's only been, a couple of years? You're doing a lot of R&D and all sorts of exciting stuff. Tell us a little bit about what your focus is.
Yeah, so, we incorporated not too long ago, a few years back, 2017. Got our first round of venture capital funding in 2018. Tri-D has a mission really to, our goal is to promote a world that's safer, more efficient, and more sustainable. And we started by a group of engineers, and what we aimed to do was to look at the infrastructure around us and say, how can we take technologies that are available now and upgrade this infrastructure to really meet the demands and needs of the 21st century? So what we're creating is industrial smart pipe and pipeline infrastructure. And what that is we're trying to get our world's infrastructure, and in our case, pipes and pipelines, to be active and reactive systems. So in the computer world and in social media software and advertising, they're able to constantly sense what's going on. They're able to be dynamic and basically monitor what is happening in real world situations, and then use that information to optimize and become more efficient in what they push to you and show you content, or in some case in advertising, sometimes it's a little annoying, but shows you ads of what you want to see. So in our case, in infrastructure, we take those principles of big data, of connectivity, of sensing and monitoring, and we implement them in hardware. And what we're able to do is now have structures and systems that are better able to react to the environment around them, to changing conditions of our world. So one of the things that you may commonly think of in this is preventive maintenance, where you're able to predict a problem before it happens, and a computer system or maybe a human operator can now enact a change, often in real time, to prevent that from happening.
Well, that's interesting. So it's really great to see you again, Alex. We first met, I guess, in Denver at the Your Tech conference, where you were doing a presentation on things that were based on sensors, and I really like the way that the smart pipe uses new kinds of sensors. But then also, it sounds like you're incorporating machine learning with that for the predictive aspect. Is that correct?
It's very correct, Susan. One of the key things that we're doing is looking to put a network of sensors out there in the world, embedded within the infrastructure that we use every day. And people don't realize that, they're kind of in the background of society, but pipes are really one of the backbone pieces of infrastructure for many different types of industries. You look at the energy industry, the oil and gas industry, the wells are created and held open and used with strong steel pipes. You look at aerospace, you look at water management. These are used everywhere, and they carry some of our world's most critical resources, talking about energy, fuel, water. We really want to make sure, especially in current day times, to make sure these products are not contaminated, that they're moving efficiently, that they're not springing leaks or becoming dangerous. And we have the technology now with distributed sensing to be able to do that. And yes, you're correct, to use things like machine learning to learn about the system and to make it more effective and more efficient.
Now, if I recall correctly, you're coming out with, was it called BytePipe, the first version of it soon?
That's correct. So BytePipe is what we've termed the design architecture for our smart pipes. And you can think of it like a product line or a family of products where we could have different products under the BytePipe name. So we first started and saw a lot of needs in the oil and gas industry for a type of pipe that they use called a casing, which is used to hold open a oil or gas well. And in doing so, it's a very critical piece of structural component, and you'd want to monitor to make sure that it is holding its integrity well, so that this well does not potentially collapse or spring a leak. And we started there. We've since seen interest from many different people in the industry to adopt this idea of a smart pipe and our BytePipe architecture towards other products. And we've started developments working towards the surveying market for drilling to gather information about soil properties. This is used for like oil platforms or even offshore wind platforms. And we've seen it in other pipe applications as well. So we're seeing the interest come out as we get the word out about what we're doing, and it's really exciting to see.
That's fine. Now, if I recall correctly, we met one of your partners, Deepak, and I think he and you both did some work at SpaceX. Am I right?
Yeah. So Deepak is our CEO, and I'm the president. We co-founded Tri-D Dynamics together. Just a brief background on us: we've known each other since about 2011. I think we met. We went to undergraduate together at UC San Diego, and then we also went to grad school together at Purdue University. Both studied engineering and aerospace engineering specifically. Deepak worked at SpaceX for some time, and I worked also in the space industry at another company called the Aerospace Corporation, which focused more, you're probably familiar with it. It focused more on military rocket launches as opposed to commercial rocket launches. But we both honed our skills and craft doing advanced manufacturing in the space industry for rockets.
Now, what motivated you to get into, obviously piping is everywhere. It's like you said, it's the foundation of a lot of things. What motivated you to start with this? Because I know you guys also have an interest in space and applications of what you're doing now in space, among other things. What motivated you to start with the oil gas industry?
Sure, yeah. So, we started off developing this technology a little bit with the applications of rockets and rocket engines specifically. We were looking at advanced forms of manufacturing, like 3D printing, different coatings technologies. And we actually started to play around with ways to use those to embed electronic components into metal structures. So we started embedding things like sensors, communication cables and wires and power sources into these components and gaining expertise there. Once we felt good that we had some new developments and new techniques that we had kind of created, we said, how can we best apply this? And we've always been really fascinated with the idea that our world does not work as efficient as it can. And, a lot of that is due to you can't not improve what you can't measure, right? So we said, okay, if we can have the ability to put sensors in different places now, where are areas where we can really gain huge improvements and really raise the potential of what we can achieve with our industries and with our manpower. And so again, we started looking to different application spaces. Obviously, for a new technology, it's going to at first be a little bit more expensive before it gets wide mainstream and scaled production. And so we needed to identify applications where they'd be willing to pay for the initial high cost because their need was also so high. And it just so turns out the oil and gas industry is going through this period of transition right now where they are looking for ways to become more efficient, and they're looking towards digital technologies. And Susan could probably speak to this, as she's been at many of these conferences and trade shows and seen really the trends in this area. I think there's this external kind of threat in the industry right now where there's sector of renewables, there's a public sentiment kind of against it, and then you mix that with drop in demand or varying demand that we saw from COVID. And a lot of firms are struggling right now to churn and maintain profits, steady profits. So they're looking at ways to get more efficient. And I think we came at the perfect time with a technology that was really interesting to them to implement into their fundamental infrastructure that they use in a lot of these oil and gas products and wells.
Well, I'm glad you mentioned that, because to me, one of the things that I've been really impressed with is the fact that it is that you're making the pipe and embedding the sensors through additive manufacturing. So as every single layer is added, the sensors are doing essentially two things. They're sensing the external thing that they're supposed to be sensing, but they're also doing the integrity sensing of the 3D printing itself. So the additive, seeing if there are lattices and if the metal is doing what it's supposed to. And to me, that's what's kind of really unique about what you're doing, because there's still a kind of hesitancy about 3D printing or additive printing because of the quality issue. So
you hit on a really good point there. That's actually something that we kind of stumbled upon and realized that was another benefit from embedding these sensors. So one of the things that we started doing was we started playing around with additive manufacturing. And I should mention, not just additive manufacturing, but we actually employ a host of metal forming techniques to embed these sensors. One of the things that we did was one of the early ones that we worked on was embedding a temperature sensor into just a piece of metal, piece of aluminum plate. And at first we were just seeing if we could do the job, embed it, and if it was strong and durable. But really what we said is, okay, if we can read the sensor in real time while we're actually embedding it, then we can also get the temperature of the metal as it's forming on this sensor, which is an important characteristic for us to measure to ensure that there's good quality in the buildup of our metal through the additive manufacturing process. And so you're right, it had a double benefit. We could measure the process itself in real time to ensure that we're getting a really reliable and high integrity part. And then the sensor's in there, and now that can be used in the part itself for whatever use it may have in its lifespan.
So interesting. And it's just an area that's going to continue to grow, because as people are trying to change, and they are changing, then they'll have unique sizes and specifications. And so you can accommodate all of that.
That's the goal. That's the idea. I'm not going to say that we're there yet to be able to do every product and all the different needs and requirements they have, but what's what we're building towards. You have to start somewhere, and I think we really turned a lot of people on this idea by just proving that the concept was possible at first, which they really didn't know. At first you think, are you going to damage the sensor? How does it actually? Is it really structurally reliable? And myself, I have a background in structures and materials for additive manufacturing, so it was important for me to show people that this material that we were forming, it's really a composite material now. It's half structural, half electrical, was able to withstand the structural integrity and the loads that it's really going to see in its lifespan. And when you talk about putting sensors in things, you want to put them in critical parts that are critical to holding up your foundation. And with that, you have to be very careful that you don't compromise that integrity.
Now, the sensors you're making also have to, or that you're buying, they have to withstand high heat and cold?
So there is a technique that we use, one of several that we use in what we call our smart metal fusion process. That's a term we coined in the company to really describe this process, this expertise in embedding electronics. So one of those is called cold metal fusion. And a lot of people kind of get the wrong idea of the cold part. It's not actually at really cold temperatures. It's relatively cold compared to other metal forming processes. And what I mean by that is usually when you form metal, you have to melt it. And these can be, very, very high heat, high temperatures, obviously. In this process, the cold metal fusion, you actually don't melt the metal. You start with metal powder, and you shoot it really fast towards whatever plate you want to build upon or part you want to build upon. And just the nature of what we call the kinetic energy impacting allows you to build up material. It allows it to stick, allows it to build up material. The analogy that we use is like if you take a snowball and you throw it at a wall, right? If you throw it too fast, it's just going to explode. If you throw it too slow, it's just going to hit and fall off. You throw it at just the right speed, it will stick. And actually, funny enough, as was discovered some years ago, metal powder acts the same way. If you find the right speed to spray the metal powder at, it will stick to what it's sprayed upon, and you could actually build up metal that way.
Yeah, that's interesting.
Oh, that's so interesting. And there's so many different aspects of that have to do with the strength of the materials, et cetera. And oh my goodness, I love this.
Now, are you thinking at all? Yeah. And as I'm listening to you, I'm thinking, so we're talking large scale projects right now. This could also revolutionize industrial building, campuses, even housing. Have you thought at any point of getting into that kind where you have the smart pipe really kind of helping when you're about to have some problems? Because a lot of times with buildings, your pipes go, you're dead. It just floods or whatever happens, and it costs millions sometimes to fix it. Something like this would be a great, what do I call it, diagnostic to just say, let's check how we're doing. Oh, yeah, we're fine. Everything's fine. Nothing looks like it's out of shape. Whereas you could tell something was going wrong with piping or a fusion of something or joints with something like the sensors. Is that something that you're looking at for the future?
That is exactly where we want to get to. Okay. We want to proliferate this technology to many use cases, including residential and commercial, city applications, water management, electrical conduit, gas line. We couldn't start there. And the reason goes back to kind of the economics of this. It's a new technology. It's a new process. There isn't a lot of scale, a lot of expertise around. There's specialized machines that we use. So it's going to be a little bit expensive at the start. And we had to say, okay, with pipes, where are the most expensive pipes in the world used? And do they have a need for sensing? And it turns out those pipes are the ones that go inside oil and gas wells. These pipes cost anywhere from around $500 to $1,000 per segment, segment being maybe 30 to 40 feet long. And the incremental cost that we would add to that is able to be absorbed because they have a need for the sensing. Whereas if you're talking maybe, a piece of copper pipe in a house, so it's going to be a couple dollars per foot or something. We want to get to that stage eventually, but it's going to take some time, and it's going to take scale to get there. The analogy I use is kind of like how Tesla, they started with the Roadster, a super high performance supercar, only made a few of them. Then they went down to a little bit cheaper car, a little bit more mass appeal. Then finally they got to their Model 3, which, it took scale to get to, it took scale in manufacturing, but it was able to be sold to many different people.
And what a lot of people don't realize, especially in the scientific and manufacturing areas, things that you see today have probably been planned 10 years ago. It takes a while. It takes a while to get out there. Tesla was talking about the battery technology, and he goes, we're 2 to about 8 years away from being where we want to be. It all depends if they can break a couple of the barriers to really put a lot more storage of energy into the batteries. And they've got new technology that they're developing now. It's just not ready for prime time. And it's about the same as what you're saying. This is the beginning of it, and sky's the limit at that point.
We see a lot of parallels with kind of new technologies like that come about. Obviously, the electric vehicles being a good example in current times. And you're right. Tesla didn't start now; they started 10, 20 years ago, and they've been building to this for a while. People think it's an overnight success, but it takes a long time to get to the point where the technology's ready. It's able to be functional, it's reliable, but also the cost is there, and that's where we're looking to also.
It's funny in the industry how that happens, because if you look at computers, that's a perfect example. what we see coming out today, SSDs or new chips or whatever, that's been worked on usually 5 years ahead of time, at least. And it's not new. It's just that we only just heard about it. And it's funny how people perceive everything as brand new when, no, it's been out there for a while. And it'll get there eventually. Sometimes products have been out there for 10, 15 years and they're waiting for inventory to fall off of older products like TVs in the old days. And then you have new products and everybody thinks it's brand new, but not quite. It's kind of fun. How excited are you guys by what's going on with what you're doing and where you see things going?
I gotta say we're really pumped right now. So some recent stuff that we've been developing and going on in our business. We recently signed a major customer. We put a press release out about a month or two ago. We're working with Marubeni Steel, a Japanese firm that is actually one of the largest distributors of these oil and gas pipes. I think they own about a quarter of the global market share in pipes that they sell. We're working with them. So, like I said, once we started getting the word out about our BytePipe architecture and our ability to embed sensors and electronics into pipes, we actually were approached by Marubeni, and they said, can you work with us to apply some sensors and electronic components to our pipes that we're selling? And the application, without being able to go too far into it exactly, is a way for us to get our feet wet in the industry. So, when we're trying to make really big changes to how people have been doing things and changing a lot with how their pipes by embedding them with electronics, like I said, these pipes are pretty important to the integrity of oil and gas well.
Sure.
It's a risky endeavor, and it's going to take, someone a lot of wherewithal to say, hey, I want to switch this right away. So all these, potential customers that we're talking to, they're saying, we would love to see this being tested in downhole or well environments. And for us, we said, okay, what are easy ways that we can identify opportunities to basically get our technology out there in these oil and gas wells, but to also generate some revenue in a quick time. And this opportunity with Marubeni, I think, is one of the opportunities to do just that. It's kind of a low risk change to their pipe. It doesn't really affect the structural part of the pipe at all, but it provides a lot of digital functionality and value in being able to track these pipes throughout their whole life cycle in the supply chain and have this digital signature that you can always go back to look on, to know where your pipes are, to know what exact pipe you are dealing with, what's the history of it, how was it made, what material is it, etc. We're able to do that in a unique way that allows these to be really rugged and robust once they go into the oil well. And I think that's, we're looking for some of these kind of quick ways to market to really test out our technology and gain confidence in the industry when people start to see this used more.
That kind of brings to mind, like we're talking about, I've been involved for a couple of years on technology and commercialization and the steps. And when you were talking about electric cars, okay, they're fortunate because they're self-contained, and it's much easier to monitor something and put it into a system if it's self-contained. If you have to work with the interface and the legacy data monitoring and cloud data management of all the sensor data with the customer, that just puts in so much more complexity. But if you're doing it in a way that you can be self-contained and these pipes go into your own cloud and they don't have to interface with the entire system, that makes it like so much easier to get started and sell it into systems.
That's really 100% our thinking lines as well. We want to make it as easy as possible for customers to adopt this technology. Often when someone's making this type of decision to change over, even if they see the benefits, a lot of times they're putting a lot on the line, their reputation, going on a limb for you. And so you want to be really sure that you're not going to let them down. And for us, we want to work with ways to get our technology out in the real world and use, not just tested in the lab, not just tested in a facility, but out in the real world where you can't really explain certain conditions that happen. They just happen. And your technology has to be able to withstand that. And so the more data we're able to gather, the more use cases that we're able to show that we have had successful deployments of our embedded technology, I think the easier it is to go up the value chain to a little bit riskier products that have higher potential revenue for us.
That makes a lot of sense.
This is fun. It's exciting. And we've seen you guys about a year ago and how far you've gone since then. And it's pretty exciting watching it grow, and especially with some of the new customers you have and what you can do with that. You know, there's only one thing you can do, and that's continue succeeding, which is great. That music means we are out of time. We're so glad you could join us and tell us about what you're up to, and I think it's just exciting. You guys are just, for us, it's exciting watching a younger generation innovate and do things, because you guys get such a bad rap as a generation, quote unquote. It's like, and some of it deserved and a lot of it not. Yeah. I mean, and it's great watching that we're still graduating great engineers and innovators. And so, yeah, it makes us happy. That's all I could say. It's, we're glad for you. And we hope you guys really succeed. I mean, it's like you said, you're starting with large scale, and then eventually you can go and do anything. It'll be cool.
Appreciate it. Thank you for allowing us to share our story, and hopefully, inspire some other people to get in this game as well.
Yeah, if you want to get a hold of Alan, there'll be information below, plus links to their website. And if you're interested, do that. And I think you guys are still looking for investors, or are you pretty much okay at this point?
Yeah, we're going through the process of facilitating investment. I think we're looking good right now in terms of what our finances are, but that's always something to look towards as we keep on growing and want to scale fast.
Yeah, that's great. Well, anyway, Alan, again, thanks. Nice of you to come on and share with us. And again, folks, if you're watching and have an interest, get a hold of them. This is gonna be big, pretty sure.
So cool. Yeah. So Alex Finch, president of Tri-D Dynamics. So cool.
Thank you, guys. Thank you both. Appreciate it.
Thank you. And if you're watching the show, please subscribe, give us any feedback, and let us know what you think. Have a good one, everyone. We'll see you next week. Take care. Bye-bye.
Bye. Thanks.